Hi everyone, myself Navyatha, working as Assistant Professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. Today I am going to discuss about the topic, the types of file organizations, and that too in those types of file organizations, especially in today's session, I am going to deal with heap file organization and hash file organization. And my overview of presentation includes what is heap file organization, what is hash file organization, and the types of hash file organizations. So let us deal with heap file organization first. Heap file organization works with data blocks. So in this method, records are inserted at the end of the file into the data blocks. So here this is a block. These are different types of data blocks in which in each block the records have been inserted. Record means whatever the data that we are going to insert. That is a row in a database, right? So here no sorting or ordering is required in this method. So we can able to insert the data randomly. We may not follow any type of sorting or ordering. If a data block is full, the new record is stored in some other block. So if at all I want to insert, here this is a data block, right? So in this data blocks I used to store the records. Clear? So if at all I want to store a record, then randomly here we can able to store the record. So here the other data block need to be very next to the data block, but it can be any block in the memory, right? So whatever the data that we are going to store, it will be searched linearly whether the next block is available or not to store that particular record. So it is responsibility of DBMS to store and manage the new records. So these are nothing but the records that I am going to store, and these are nothing but the data blocks. Okay. See here R1 is used to stored in the third block. R5 is used to stored in the third block. Next R6. So here these are the records which are entered in a sequential manner, and those records, see here whenever the block is full, then the next record will search for immediate next block, and whenever this block is full, it will search for immediate next block. So in this manner we used to store the records. Have to insert a new record. Suppose we have 4 records in heap, that is R1, R5, see here R6, R4 and R5. Here R5 has been repeated. Okay. So suppose a new record R2 has to be inserted in the heap. Since the last data block, that is block 3, is full, it will be inserted in any of the blocks selected by the DBMS. Let's say the data block is 1. Here rest of this is block 1, this is block 2 and this is block 3. Okay. So only block 1, block 2 has been filled, and here in block 3 there is one slot is free. Therefore, whatever the record has been entered recently, that will go there and it will be stored. Okay. So in place of R5 here, we can say R3. Okay. Let's replace that one. By mistake, it has been printed like R5. Okay. Or else the same data can also be placed. That is what we call as redundancy in our database. But maintaining redundant data in a database is not a good approach. Okay. For that purpose, to remove the redundancies, we use the concept of normalizations, or we used to decompose the tables. That is the reason here I have changed R5 to R3 here. Next, what is hash file organization? Till now we have discussed about heap file organization, in which the files which we are going to insert will be checked linearly, the block by block. If at all one block is full, then it will be it's inserted into the next nearest block. That is what the concept till now we have dealt. So what is hash file organization? Hashing techniques are used to retrieve specific data. So here in this hash file organization, we use one hash function to generate a particular address, and in that particular address, the record will be stored. So how to generate that address? By using hash function. What is that hash function? With the help of keys and with the help of hash function, we used to generate the address where we should keep that record. Right. So hash file organization uses the computation of hash function on some fields of the records. So this is what the function which is used to generate a particular address to keep the record. The hash function's output determines the location of a disk block where the records are to be placed. Okay. So in this method, there is no effort for searching and sorting the entire file. So we may not search whether this block is full or whether this block is empty, like that we may not check. Okay. Randomly, the hash function will generate one address, and in that address we can keep that record. Okay. So in this method, each record will be stored randomly in the memory. Hash file configuration is also known as direct file configuration. So what is the other name of hash file organization? Direct file organization. That means here directly we are generating one address and we are keeping that record into that particular address which was generated by the hash function. Okay. So in hashing, we mainly refer the following terms. What are those following terms here? The data bucket. What is a data bucket? And what is a hash function? What is hash index? So let us discuss about these three terminologies now. What is data bucket? Data buckets are the memory locations where the records are stored. These buckets are also considered as units of storage. Wherever the records are stored, those records here will be kept in a particular block. That is what we called as a bucket here. Okay. So these are also considered as unit of storage. Next, what is a hash function? So hash function is a mapping function that maps all the set of such keys to actual record address. Generally, hash function uses primary key to generate hash indexes. That is here. Let us discuss this one with a simple example. So if at all, this is what the SID, student ID, for example, 10, 20, 30. Okay. And this is what the student name, for example, XYZ. This is the table. If at all I want to insert this particular data into a particular record, where should I? I want some address, right? Some location to store this particular record and this particular record and this particular record. Let us suppose I used to take the hash function as k modulo 5. Okay, k modulo 5. What is k here? It is any kind of key. That means here whatever the key attribute here I am going to take, that attribute can be considered as k here. Okay. So let us suppose here SID is the key attribute. SID is the key attribute. So what will be the hash function? K modulo 5. So here what we have to do? 10 modulo 5. So what is 10 modulo 5? What is 10 modulo 5? That is nothing but 0. So in the block 0, see these are the blocks 0, 1, 2, 3, right? So in the block 0 which was generated by this function, hash function, the address which was generated is 0. So at this 0 location, this record will be stored. Okay. For example, let us consider the second thing. Okay. So 20 modulo 5, or else here let us suppose I can modify it as 21. Okay. 21 modulo 5. So modulus means we have to take obviously what the remainder. Right. So here, so what is the address generated by what? K modulo 5 or else 1. Right. So at location 1, 21 will be stored. This record will be stored. So in this manner, we can able to generate the addresses by using the hash function. Right. Some k modulo 5, k modulo 10, whatever the hash functions we may take what kind of many number of hash functions, like whatever the approach, division method, like that. Okay. This is one of the division methods that I used to follow. Okay. So hash function can be simple mathematical function to any complex mathematical function. It can be very simple and it may be also complex too. Right. Here I have chosen what? Division. And hash index. The prefix of an entire hash value is taken as a hash index. Every hash index has a depth value to signify how many bits are used for computing hash function. So what is hash index? That is nothing but the prefix of a hash value. That means here in more sessions, we used to convert the decimal part into the binary representation. So in those representations, in binary representations, we used to consider least significant bits and most significant bits. Okay. So in that particular moment, we use these kind of hash indexes. Okay. So these are nothing but the search keys, and applying hash function on these search keys will produce the addresses, and the records has been kept in this particular address which was generated by this hash function. Okay. See here 101 is the search key, and by applying some hash function, the address has been generated randomly at this place, and that particular record will be kept here. Okay. So in this way, randomly in a direct approach, we used to keep the records. What are the different types of hashing here? So mostly we have two types of hashing, static hashing and dynamic hashing, right? So what is static hashing? And in this static hashing, we have again two categories. Okay, open hashing and closed hashing. In this session, especially we used to deal with static hashing and the types of static hashing, and in the next section, I used to discuss about dynamic hashing. So what is static hashing? In static hashing, the resultant data bucket address will always be the same. That means if we generate an address for employee ID 103 using the hash function modify. This is what the division method, which again I have used. So here employee ID, the key is what here? 103. And what is the hash function? Modify. Okay. So then it always results the same bucket. What is the bucket address? It will be obviously 3. Here there will be no change in the bucket address. Okay. Hence it is static. There is no change. It is fixed. Based upon the hash function and the key value, the address will be generated, which is fixed. That is why the name itself, it is static. Okay. The number of data buckets in the memory remains constant throughout. So these are the data records. Okay. And by using hash function in between, okay, these records will be kept in a particular address locations. These are the address locations which have been generated by using hash function. Okay. So at this particular address location, I used to keep this record. At this particular location, I used to keep this record. At this particular location, I used to keep this record. In this way, we used to store the records. So these are the terminologies here. These are nothing but the data records, actual records. Okay. These are nothing but data bucket address. Okay. Which is generated by the hash function with the help of keys. Okay. Next. So this is the actual data in the memory. So this whole thing is called as what? Data buckets in the memory, including the data and the address. That is what we called as data buckets in the memory. Okay. Next, what are the operations that we used to perform here? Searching a record, inserting a record, deleting, updating, whatever the operations that we used to do with the DBMS, those operations obviously, right? Here, so when a record needs to be searched, then the same hash function retrieves the address of the bucket where the data is stored. Whatever the hash address generated by the hash function, that will be retrieved. We can go there and we can retrieve the data record. How to insert? When a new record is inserted into a table, then we'll generate an address for a new record based on the hash key, and the record is stored in that particular location. Delete a record. To delete it, same, the address we used to delete a record, we can go to the particular address and we can delete that record. See, we'll fetch the record which is supposed to be deleted, then we'll delete the records for that address in the memory. And what to update a record? Update a record, we'll first search it using a hash function, and then the data is up. First of all, we used to search whether that is available, and then if at all it is available, we can able to update or delete. Okay. These are the operations that we used to deal. Next, If you want to insert some new record into a file, but the address of a data bucket, that means till now we have inserted whatever the address that has been generated. In that address, we used to insert the data. Okay. Now, let us take this example. For example, these are the records 10, 20, 30. Okay. And these are the key values. That is nothing but some student ID or employee, whatever it may be. And I am going to take the function k modulo 5. Okay, k modulo 5. Then, for this 10 modulo 5, what is the result? 0. So, this is what 0, 1, 2, 3. These are the buckets, right? In this bucket, we used to store the data. Okay. So, the first element 10 must be stored in the 0th location. Okay. Next, let us take 20. What is 20 modulo 5? That is also a 0. That means here the bucket size is only 1. Let us assume the bucket size may contain number of elements 1 or 2 or 3 based upon the memory size. Okay. So, if at all assume this bucket can hold only one element at per time, right? So, here the second element 20 which has been generated by the hash function is 0, which is already occupied. So, what we have to do then? This is what the problem that we used to face. This problem is called as bucket overflow. What we call bucket overflow. That means here, see, if you want to insert some new record into the file, but the address of the data bucket generated by the hash function is not empty, the same situation, or data already exists in that address. In this address, data already exists. Okay, then what we have to do? This situation is in static hashing is known as bucket overflow. Okay, so this is critical situation in this method. To overcome this situation, there are various methods. Some commonly used methods are as follows. So, to overcome this situation, we have two common methods. What is that one? Open hashing and closed hashing. So, let us discuss with these two hashings briefly. What is open hashing? So, when a hash function generates an address at which data is already stored, then the next bucket will be allocated to it. Right. So, here, what is open hashing? See, 10, the first element has been inserted successfully. What is the second element? 20. Here, see here, it also generates the address 0. Right. So, it will automatically go and search for the next block, whether the next block is free or not. If at all it is free, then the record will be placed here. So, in that a linear manner, it will check, right? So, it will check whether, if at all this block is empty, this block is full, then it will check for the next other block, immediate blocks. So, in that manner, we used to linearly check whether which block is free or not. If at all it is free, then that record will be placed in that block, otherwise not. That is what open hashing here. See, and this mechanism is called as linear probing. So, here what we are using in linearly, we used to check one after the other, whether this block is free or not. If at all it is free, then we used to insert the data. If at all it is not free, then again we used to check the immediately next block. Okay. For example, suppose R3 is a new address which needs to be inserted, then the hash function generates is as 110 for R3. That means for R3, the hash function is 110, but 110 has already been occupied. Okay. See here, this example can be represented with a diagram. See here, the new record is R3, and by applying some hash function, first of all, I got the address as here 110. Okay, but the data has been already there. Okay, therefore, here I used to check whether the next block is free or not. If at all it is free, then I can place this one, or else I used to check the next linear block. If at all it is free, then I can place this one here, or else I used to check. In this way, I used to check linearly. That is why the method name itself represents linear probing. Okay. So, in this way, but the generated address is already full. So, the system searches the next available data bucket 113 and assign R3 to it. That is what here. Okay. Next, what is closed hashing? So when buckets are full, then a new data bucket is allocated for the same hash result and is linked after the previous one. So this is just like linked list. If at all the bucket till now what has been happened, these are the data we have and these are the locations 0, 1, 2. So if at all this generates address 0, this also generates address 0, this generates for suppose address 1 with some hash function. Okay. So if at all the first record has been kept in that particular address which has been generated by hash function. For suppose 20 also generates address 0. Okay, but here the data is already there. Here we are dealing with what the closed hashing. Closed hashing means here one more node will be taken and at this particular 0 location only, one more node will be taken and it will be linked with the previous node. That is what here closed hashing. So here a new data bucket is allocated for the same hash result and is linked after the previous one. This mechanism is known as overflow chaining. So why? Because it is a chaining method. Okay. So let us deal this one with a simple example. See here, if at all I want to place the new record R3 by using some hash function which generates 110. 110 has already filled. Then what I should do? I used to create a new node and I can fill this new record in this particular new node and I can link this new node to this particular previous one. This is what closed hashing is meant for. Okay. So what we have discussed in this session, we have discussed about two file organizations, that is heap file organization and hash file organization. So what is heap file organization? We used to arrange the data records in a sequential manner, okay, in the data blocks. What is hash file organization? By using hash function concept. We used to generate a particular address and in that particular address we used to keep the records. If at all the address generated by the hash function for more number of elements is same, then it is called as overflow condition, bucket overflow, and it can be resolved by two methods, that is open hashing and closed hashing. Okay, in open hashing we use the technique linear probing and in closed hashing we use the technique what? Chaining method. Okay, so in the next session let us discuss about the second type of hashing, that is nothing but dynamic hashing. Thank you.